Then chapter 7 have 1, chapter 8 has 1, and chapter 12 have 1. And then chapter 11 is debatable. Okay? So based on lay down this foundation, so you should be able to study well. Now for the special project, we will advise you to look into those 5 items, which is interest you most. Then go down to VTV places and then ask for the menu, either Physics 1A menu, Physics 2A menu, or Physics 1B menu. And then pick the part of the lab you want to do, make copies. Like one of the group year students, he's already picked the lab on the yarn modulus elastics measurement. Okay, or mass. Okay, there's a 2 explanation about this. That means if an object is irregular shape, there's 1 point, in which case called CM. So what is CM? Center of mass is a point at which we consider all the mass is concentrated at. So for better English, at a point at which we consider all the mass is concentrated. So this is one type of explanation. Another one is center of mass in your book, in which case CM is he like to say that is the average position of the system's mass, So that's how they define. So in generally, they try as far as physics go. They say, okay, we take 2 mass, and this is the M2. And then here is x-axis. So this is the coordinate system 0, 0. So they're using this as the starting point. So what you do, how you define as an average. Namely in here, M1, M2 is not equal. It's not the same distance, same mass. So it says, let's say this is x1. Distance x1. And then I like to say this distance is x2. Okay? So he says, how about that? Maybe the x1, x2, the center of mass is someplace in here. So they say this is considered as center of mass around the x-axis. So according to this, they say, okay, so reference point, what is means the average distance? Center of mass is equal to m1 x1 plus m2 x2 divided by m1 plus m2. So basically, this is considered average position of the system's mass. So then it extended in y direction. So if it's a y direction, they can using the same technique. Y center of mass, y1 plus m2 y2 divided by m1 plus m2. So now, if there's more than one particle is much more than that, then what would that have? They have a lot of it, and then is in 2 dimensions. Later on, you can extend it to 3 dimensions. Okay, so in these cases, we like to say this is the x-axis, and this is the y-axis. So this is the object is like in here, in here, in here, in here. It's all over the places. Then what is the average distance then? For each one of them, maybe this one is m1. And then in these cases, we like to indicate that as a vector. Vector, this is distance is ri, and so forth. So what is the average distance then? The r center of mass in the vector form is equal to summation of mi, I equal to 1 to all the way to n. And then what's the rest of it is equal to m1 r1 plus m2 r2 plus m3 r3 plus m4 r4, like this. And then so to be like this is the general formula for center mass in 3 dimensions. And if you see in the 1 dimension, you written in x and xy and xcm or ycm, zcm, then it turn out to be summation of I, mi, xi, you like to say n divided by m, or equal to summation of I, n is center of mass in the 3 dimensions. So now, if you have a continuous object, the object is not each independent particle. Suppose you have a solid object. Suppose you have a solid object, then what will you do? So the solid object is, we drew the picture. So here is the x and y. This is an irregular shape. So in this case, we say, oh, right in here, a little mass called dm. Have a little mass called dm. So in these cases, we like to find out what is this is r function. So then what is, in these cases, the center of mass in the 3 dimensions? Then the center of mass in the 3 dimensions is equal to integration of r dm divided by capital M. So continuation object. Then what if along each individual x-axis and y-axis, then you do this. X center of mass is equal to 1 over m integration of x dm. And then, of course, this is the r dm. And then ycm is equal to 1 over m and integral of y dm. And then zcm, that equal to 1 over m, and then integral of z dm. So this is a 3-dimension consideration around 3 different center mass in the different axes. For this one, have a very good example for calculate center of mass is example 8.12. 8.12. We want you to study up on it. There might be one potential testing problem. That's important. So the next we like to say is a lot of things happen in the United States, especially high tech. It's occurred in Pasadena. Pasadena in the neighborhood. One of the things is called a rocket. Rocket originally is come from California. We have a very important laboratory, 6,000